Okay, so let's take a look at some compound inequalities, and let's take a look at some intersection sets or compound equalities joined by the word "and." We have three examples here. So x is greater than -1, and x is less than n equal to 3. So here we go. So first I'm going to graph each of these separately. So x is greater than -1. There's my -1. And goes all the way that way. I'm going to stay on the same number line, but use a different color. So x is less than or equal to 3. Looks like that. Okay, now, when we are using the word "and," we are creating an intersection set. So we need to take a look at our two graphs, and in the new graph, choose only points and values that are present in each of the graphs. And so what we're looking for is a place with "and" where there is an overlap. And I can see that there's an overlap right here. Okay, this is where overlap is. So if we take a look at the extreme right, 3 is in both of the sets, because the 3 is colored in here in green, and it's in the red portion in red. 3.1 is not in both sets. 3.1 is part of the red set, x is greater than -1, but it is not part of the green set, because 3.1 is not less than or equal to 3. So 3 is going to be our extreme right edge of our new compound equality graph. Okay. Now the other point that we need to look at is what's happening at -1. Now -1 is not part of both sets. Okay. It is part of x is less than and equal to 3, so part of the green graph, which you can see because the line goes right through -1, but it is not part of the first inequality. X is not, -1 is not greater than -1. So we're going to go down here and circle it, and we're going to join, because all of these values are part of both of the inequalities above. Okay? And how we're going to write this is we're going to say, okay, -1, x, and 3. So in order to belong to this set, it has to be between -1 and 3. So it has to be less than 3, and -1 less than and equal to 3, and -1 is going to be less than x. Now, what I want you to see is that this part of the inequality is exactly the same as what we have written up here. This part of the inequality is a flip of what we have written over here. All we've done is flip it around and write it like that. They're the same thing, but then we fuse them together into one compound inequality. Okay? So that's how we would graph that one. So let's just get rid of some of this so we can get on to the next one, which is going to be different. Okay, so again in red for the first one we have x is less than or equal to -2. So equal to -2 and less than -2. There we go. In green, x is greater than 1. Now, when we take a look at this, remember that we're using the word "and." And means that we're making an intersection set. So we're looking for what values on the number line are found in each inequality. Are there any values that will work to make each inequality true? And when we're looking at the graphs, we're looking for an overlap. There is no overlap, which means that there is no solution. So what's the compound inequality? It is, well, there is none. There's no solution. So that's what we write down in lieu of a compound equality with two inequality symbols. And what do we graph? Absolutely nothing, because there is no solution. Okay? Simple but tricky. Okay. And the other thing that can happen is what happens over here. So I'm going to graph the first one in red again. So x is greater than and equal to negative 6. Equal to and greater than. Good. And in green, x is greater than negative 2. So this is an intersection set, so we're looking for overlap. We're down on the second number line, we're only going to graph in blue those values that make this inequality true and this inequality true. Well, these values, from negative 6 all the way to negative 2, they will work for x is greater than and equal to negative 6, but they will not work for x is greater than negative 2, because they aren't greater than negative 2. These values here are less than, and in this case equal to, negative 2. So they will not work for this inequality. Because this is an AND compound inequality, we cannot include these values in our inequality. So we're going to go with negative 2, but not include it. But all of these values to this side, we can see, are included in the green inequality and the red. They're in both. So we are, with these values right here, and on that way, we are satisfying both inequalities up here. So that is our compound inequality graph. The solution then is just, well, what does this graph say? If I took a look at this graph and wrote an inequality, I would say that x is greater than negative 2. So, when we have inequality signs that are pointing in the same direction, just like this, I've circled them, okay, we've got greater than and equal to. We're going to end up with graphs that, these two graphs here, are pointing in the same direction. In this case, they're going to the right. So that means our solution down here is going to be a single ray that starts at one point, in this case negative 2, and goes to one direction. When you have that, your solution is only going to be a simple inequality. In this case, x is greater than negative 2. Okay, next video we'll take a look at the OR statements.